Good morning, everyone. I am Professor Ankur Shrivastava of UC Department. Today's topic is concepts of measurement. In this topic, we will cover measurement, instrumentation, errors in measurement, calibration, and standard. Measurement is a comparison between a standard and what we want to measure. Two quantities are compared. The result is expressed in numerical values. Basic requirements for a meaningful measurement. The standard used for comparison purpose must be accurately defined and should be commonly accepted. The apparatus used and the method adopted must be provable. Methods of measurement. Direct methods, indirect methods. Instruments and measurement system. Measurement involve the use of instruments as a physical means of determining quantities or variables. Because of modular nature of the elements within it, it is common to refer the measuring instrument as a measurement system. Evolution of instruments. Mechanical, electrical, and electronic instruments. Mechanical, these instruments are very reliable for static and stable conditions, but their disadvantage is that they are unable to respond rapidly to measurements of dynamic and transient conditions. Electrical instruments, it is faster than mechanical, indicating the output are rapid than mechanical methods, but it depends on the mechanical movement of the meters. The response is 0.5 to 24 seconds. Electronic instruments, it is more reliable than other systems. It uses semiconductor devices and weak signals can also be detected. Classification of instruments. Instruments are classified as absolute instruments, secondary instruments. Further, it is classified as deflection type instruments, null type instruments. Functions of instruments and measuring system can be classified into three. They are indicating function, recording function, controlling function. Application of measurement systems are monitoring of process and operation, control of process and operation, experimental engineering analysis. Types of instrumentation system. Intelligent instrumentation. In this, data has been refined for the purpose of presentation. And dumb instrumentation, data must be processed by the observer. Elements of a generalized measurement system. Primary sensing element, variable conversion element, data presentation element. In primary sensing element, the quantity under measurement makes its first contact with the primary sensing element of a measurement system. In variable conversion element, it converts the output of the primary sensing element into suitable form to preserve the information content of the original signal. In data presentation element, the information about the quantity under measurement has to be conveyed to the personnel handling the instrument or the system for monitoring, control, or analysis purpose. This is a block diagram of an instrumentation system. These are the functional element of an instrumentation system. Static characteristics of instruments and measurement system. Application involved measurement of quantity that are either constant or vary slowly with time is known as static. Accuracy, drift, dead zone, static error, sensitivity, reproducibility, static correction, scale range, scale span, noise, dead time, hysteresis, linearity. These are static characteristics. Accuracy, it is the closeness with an instrument reading approaches the true value of the quantity being measured. True value of quantity may be defined as the average of an infinite number of measured values. Sensitivity is defined as the ratio of the magnitude of the output response to that of input response. Static error, it is defined as the difference between the measured value and true value of the quantity. It is also called as the absolute static error. Scale range, the scale range of an instrument is defined as the difference between the largest and the smallest reading of the instrument. It is scale span. It is the difference between the highest and the lowest point of calibration. Reproducibility is specified in terms of scale readings over a given period of time. Drift is an undesirable quantity in industrial instruments because it is rarely apparent and cannot be maintained. It is classified as zero drift, span drift, or sensitivity drift, and zonal drift. Dynamic characteristics of measurement system. The speed of response, measuring lag, fidelity, and dynamic error are the dynamic characteristics of measurement system. Speed of response, it is defined as the rapidity with which a measurement system responds to changes in measured quantity. It is one of the dynamic characteristics of a measurement system. Fidelity it is defined as the degree to which a measurement system can indicate changes in the measured quantity without any dynamic error. Now, what is dynamic error? Dynamic error is the difference between the true value of the quantity changing with the time and the value indicated by the measurement system if no static error is assumed. It is also called measurement error. It is one of the dynamic characteristics. Measuring lag. It is the retardation delay in the response of a measurement system to changes in the measured quantity. It is of two types. Retardation type, the response begins immediately after a change in measured quantity has occurred. Time delay, the response of the measurement system begins after a dead zone after the application of the input. Errors in measurement, we can classify errors as limiting errors and known errors. And known errors are also classified as gross error, systematic error, and random error. Gross errors, human mistakes in reading, recording, and calculating measurement results. Systematic error can be classified as instrumental error, environmental error, and observational error. In instrumental error, these errors arise due to three reasons: due to inherent shortcomings in the instrument, due to misuse of the instrument, due to loading effect of the instrument. Environmental error, these errors are due to conditions external to the measuring devices. These may be effects of temperature, pressure, humidity, dust, or of external electrostatic or magnetic field. Observational error, the error on account of parallax is the observational error. Random error, this is also known as residual error. These errors are due to a magnitude of a small factor which change or fluctuate from one measurement or to another. The happenings or disturbance about which we are unaware are lumped together and called random or residual. Hence, the error caused by these are called random or residual errors. Calibration. Calibration of all instruments is important since it affords the opportunity to check the instruments against a known standard and subsequently to find errors and accuracy. Calibration procedure involve a comparison of the particular instrument with either a primary standard, a secondary standard with a higher accuracy than the instrument to be calibrated, and an instrument of known accuracy. Standards. Standard is a physical representation of a unit of measurement. The term standard is applied to a piece of equipment having a known measure of physical quantity. Types of standards. International standards. These are defined based on international agreement. Primary standards. These are maintained by national standards laboratories. Secondary standards. These are used by industrial measurement laboratories, and working standards. These are used in general laboratory. Thank you.